What's going on, guys? This is Christopher Bridges doing another YouTube video here today talking about PostgreSQL installation, configuration, and security hardening on Linux server. As well as every single time, guys, leave a like, comment, and enjoy the video, guys. All right. All right. So we're gonna start off with the introduction to PostgreSQL. First, we're going to go over the overview. Basically, it's a advanced open source object relation database management system. It is widely used for large-scale data applications that require complex queries, high scalability, and reliability. It's developed by a global development group. Its license is released under a open source license, allowing users to freely use, modify, and distribute it. And then as far as the compliance, it supports the SQL standard with extensions, and it offers transactional and relation database management features along with advanced data types like JSON arrays and user-defined types. Key features would be ACID, highly extensible, um, the control system of it, and indexing options, foreign database wrappers. So as far as ACID, ensures that the transactions are processed reliable and ensure that the database remains in consistent state even after power failures or system crashes. Extensible allows users to define their own data types, operators, and even functional languages. And then the control system would uses MVCC, which is multi-version conference control for efficient handling of multiple users and preventing conflicts between transactions. The options would be that the PostgreSQL supports multiple types of indexes such as B, Btree, hash, gist, gen, brin, and more. And in the folder foreign data, this allows PostgreSQL to connect to other databases like Oracle, MySQL, and even NoSQL systems like MongoDB. Okay, so now we're going to go over the applications and use of cases. I got 5 here on the screen. Basically, we're just going to go over the cases, the examples, and then just go over the applications. So as far as the common use of cases there are, would be one of them, or the common applications there will be 5 of them. The first one will be web applications. It's often that the backend database for dynamic web applications due to its scalability, flexibility, and easy of interrogation with web frameworks like Django, Ruby, or Rails, Flask, and Spring Boot. Examples for this would be large-scale websites like Instagram, TripAdvisor, and Apple. The next one we're going to talk about is data warehousing and business intelligence. Basically, with this one, complex queries and data aggregations, making it an ideal choice for data warehousing solutions. It can efficiently handle large data sets and complex joins, and it was powerful and has powerful features for analytic queries. Number 3, um, the extension is widely used throughout the database for storing, querying, and analyzing geographic and spatial data for like QGIS, ArcGIS, GeoServer. All these rely heavily on SQL for spatial data storage and processing. For example, OpenStreetMap using SQL with GIS extension for mapping data. And then number 4, financial services is used in banking, investment, and service systems for storing financial transactions and running complex queries. This uses trading platforms, accounting systems, and financial reporting due to its reliability and security. And then the last one would be the applications. It's commonly used for software as a service applications because of its performance, multi-tenancy support, and advanced security features. Example would be Salesforce. Salesforce uses SQL as part of its infrastructure for multi-tenant applications. Okay, so as we go to the next slide, we're going to go over the SQL security. Since it's often used for mission critical applications, it's essential to implement proper security practices to protect the integrity of the database and the data that it holds. Without strong security controls, the database could be vulnerable to data breaches, unauthorized access, and attacks. So the first few options that we're going to go over is security risks. I got three of them on here on the screen. So basically we're going to go over unauthorized data access, SQL, injection attacks, and denial of service. For the first one, without proper access control, an attacker or unauthorized user can gain access to sensitive data. And then the mitigation, this implements role-based access controls and strong authentication methods to restrict access to unauthorized users. Next one would be SQL injection attacks. Attackers might exploit poorly coded queries to inject malicious SQL into your database, which can modify or extract data or even delete critical records. As far as mitigations, the statements in your application's codes to avoid injections or vulnerabilities for, I would say, like prepared statements and everything like that. And then the last one would be denial of service. Attackers can overwhelm SQL with excessive queries or malformed requests, causing the database server to crash or become unresponsive. The mitigation, this use rare limiting secure databases configuration settings and proper firewall rules to prevent malicious traffic for reaching the database server. And then the importance of database hardening. Um, SQL, like any other server or software, it requires regular updates and hardening against new and emerging threats. And then the hardening ensures that the database is secured and only allows the necessary access, reducing its vulnerability to attacks. And then I got a couple security measures here on the screen as well, involving encrypt data at rest and transit, audit database activities, and the least privileged access. Okay, so now we're going to be talking about the PostgreSQL hardening recommendations on this slide and the next one. The first one I'm going to go over is restrict remote access. Why? To limit who can connect to Postgre to reduce attack surface. The action would be to obviously restrict access through the firewall. Example would be this code as you can see on the screen. Next would be to enable strong authentication. Why? It's because you want to use strong passwords, hashing methods to prevent unauthorized access because of this. And then the action would be to change to use this instead of to secure MD5. And then you want to use this code down below. And then number three would be to keep PostgreSQL updated. Why is because you regularly want to patch and update fix known vulnerabilities. As you can see on the last slide, vulnerabilities is super important to watch out for. And then the action would be to set up automatic updates or regularly check for PostgreSQL updates. And you want to use this code as well. Now, configuring PostgreSQL to listen on default port is a few main things. The hardening recommendations were just on one slide. This one, we're just going to go over the configurations of the default port. Steps to do that would be to install. Next step would be to edit and then third step would be to edit as well, and then the fourth step, final step, would be to restart. Now, as far as the first step, you want to install PostgreSQL by using this code as you can see on the screen, and then next you want to edit PostgreSQL by using this code on the screen. This allows listening on all interfaces. Next, you want to edit this code that you see on the screen. This allows remote access or restrict to specific IPs and uses Scram 256 for stronger authentication. And then lastly, you want to restart SQL to apply changes by using this code you see on the screen. Next, we're going to be going over verifying PostgreSQL and it's listening on port 5432. All right. Now, this will be a default port, and the steps. First step would be to run the following command to confirm the PostgreSQL is listening on this port by using this code, and then the expected output would be this code as you can see on here. This confirms that the PostgreSQL is listening on all interfaces for incoming connections on port 5432. Now, scanning for PostgreSQL with Nmap for Kali server is the next slide that we have here in the video. The steps for that would be to form a Kali Linux server, scan the PostgreSQL port for 5432 on the target server by using this code, and then the expected Nmap output would be this code as you can see on the screen. This confirms that the PostgreSQL is open and accessible on port 5432 from the Kali server. Okay, so now as we reach the final part of the video, we're going to talk about the conclusion of this, which is the summary of the conclusion of PostgreSQL. SQL is just a powerful database system that requires secure configuration and regular updates, just so that way you're not, you know, easy access for vulnerabilities on the server. Key hardening recommendations would be to restrict remote access, enable strong authentication, regularly update SQL, and then after configuring SQL to listen on port 5432 using tools like Nmap, it always helps verify that it configures the configuration is correct and accessible, just so that way everyone's able to use it. All right, guys. So now that we're at the end of the video, I'm just going to leave the floor for any questions. If there's not any questions at all, I'll just catch you guys in the next video. All right. I'll see you guys later.